All right, we're going to talk about chemical bonds. Okay, so chemical bonds are formed through compounds. So compounds are substances that are made up of two or more atoms or elements. So here's an example of a hydrogen atom and a hydrogen atom with a chemical bond between them, and they make a compound of H2. An oxygen atom and an oxygen atom together, bonded together, and they make a compound of O2. For example, down here we have a nitrogen atom and two oxygen atoms, and they form bonds between each other, and that is NO2, or nitrogen dioxide. These are all examples of compounds that are created when you have two or more atoms that combine via chemical bonds. Chemical formulas. So this might be a new thing for you. A chemical formula tells us what elements a compound contains and the exact number of the atoms in those elements. So vinegar, for example, vinegar or acetic acid is made up of H bonded to 2 carbons, hydrogen, 3 hydrogens, and and 2 oxygens. Sand is made of silicon dioxide, and it's made of 1 atom of silicon and 2 atoms of oxygen. Stomach acid, or hydrochloric acid, is made up of 1 hydrogen and 1 chlorine. Cane sugar, or sucrose, is made up of 12 carbons, 22 hydrogens, and 8 oxygens. So chemical formula symbols. So the very first thing you need to understand is a subscript. And the subscript represents the number of atoms in a molecule of a particular element. So here's the subscripts, and that tells us how many hydrogens there are, how many oxygens there are, how many hydrogens there are. And if there's no subscript, okay, that means that there's just one of those types of atoms. So 2 hydrogens, 2 oxygens, 2 hydrogens, and 1 oxygen. Also, you might see coefficients, and coefficients tell you how many of those compounds there are. So while this tells you how many atoms are in the compound, this tells you how many of those specific compounds there are. So there's 2 hydrogen 2s. So in other words, if we were to count atoms here, we'd have the original atom, which has 2 hydrogens bonded together, and then we'd multiply that by 2, which would be 4 total hydrogen atoms. This one doesn't have a coefficient, so that just means there's one of those atoms. So total atoms in this compound is 2. Here we have another 2, another coefficient of 2, so that means that in the original compound there were 2 hydrogens and 1 oxygen, but we have 2 of those molecules, so we are going to have a total of 4 hydrogens and 2 oxygens on this side of the equation. So when you're breaking it down, I don't know why this is so fuzzy, but when you're breaking it down, essentially you just look at how, what you're looking at. So H2O, so we know there are 2 hydrogens and 1 oxygen molecule. That also means 1 molecule of water. 2 hydrogen atoms, 1 oxygen atom, bonded together. When you have a coefficient, okay, you have 2 molecules of water, a total of 4 hydrogen atoms and 2 oxygen atoms. Now in this last one, you're no longer actually in water. H2O2 is actually hydrogen peroxide. 2 hydrogen atoms and 2 oxygen atoms. Okay, now the superscript. So you'll only see this sometimes, and we're going to learn about superscripts, about where they're located and what their charges are, but superscripts represent the oxidation number or charge or the amount of electrons that have been gained or lost. Now remember that every single atom wants to have a full outer shell. And remember, a full outer shell for everything except for those first 2 elements, a full outer shell is 8. Okay, there should be 8 electrons in that full outer shell. So it's a lot easier for an atom, if it has 1 in its outer shell, to lose that 1 and become charged than it is to gain 7 more. Okay, it's a lot more work to gain 7 electrons than it is to just be like, here, somebody take this, and lose your 1 electron. And because of that, we can say that when that happens, it gives it a charge, okay? And we'll look at that in a second when we look at the periodic table. Bonding. So atoms form compounds to become chemically stable. That's the only reason to form compounds. And when I say chemically stable, that means that their outermost shell is made or has 8 electrons in it. An atom is chemically stable when the outer energy level or shell is complete or full. Remember, as I say again, the outermost energy level holds 8 electrons, except in the case of hydrogen and helium, where it only holds 2. A chemical bond is a force that holds atoms together in order to make them more stable. So bonding, the purpose of bonding is to help both atoms involved get to that stable state, that state where their outermost shells are full. Now we have our metals and our nonmetals, and I wanted to refresh that with you really quick, and we're going to turn back to that in a second. But remember that all of these guys are metals, and all these yellow ones, I guess I'll move that down there, are nonmetals. Okay, and these are metalloids. We really won't use those too much until you get to high school, but those are the metalloids. These are the nonmetals. These are the metals. So chemical bonds. So there are two main types of chemical bonds. There's ionic bonds. An ionic bond is when one atom is like, I want to give you my electron and actually lose it forever. And the other atom is like, I will take that electron, thank you very much, and he keeps it forever. Now, when that happens, when you give one of your negative charges to somebody else, you become positively charged. When you accept an electron, remember an electron is negatively charged, so when you accept a negatively charged particle, you become negatively charged. So right here, this guy is now positive because he gave away a negative charge, and this guy is now negative because he accepted a negative charge. We all remember that positives and negatives attract. So when that happens, they are attracted together because this guy is positive and this guy is negative, and they are attracted and they like each other. So the attraction between opposite charges of ions is what causes this bond. Ions is something that is positively or negatively charged. So an ion is just anything that is charged. It can be charged by losing more than one electron. It can be charged by just losing one electron. But it is anything that is positively or negatively charged. And ionic bonds only happen between metals and nonmetals. So when you're looking at this, if you see the first one in the metal area and the second one in the nonmetal area, you know an ionic bond has formed between them. And so you can kind of picture how this went. One gave it to the other, one became positively charged, one became negatively charged, and they attracted together. The second type of bond is covalent bonding. That's when they share electrons. And these usually happen between two nonmetals. And you can form multiple bonds, meaning they can share more than one electron. If they share more than one electron, they make potentially a double bond or a triple bond. But essentially what happens is in that outermost shell, they'll combine, and you'll notice here carbon is representing its electrons in green, and oxygen is representing its electrons in red. So carbon is like, I will share my 2 electrons in my outer shell if you share 2 of your electrons in your outer shell. And so now if you count them, oxygen technically has 1, 2, 3, 4, 5, 6, 7, 8. So he's happy in his outer shell. Carbon, okay, had to share 2 electrons here with oxygen, but also has to share 2 more with this oxygen over here. And so now he has 1, 2, 3, 4, 5, 6, 7, 8. So that carbon is happy. And oxygen, the same way before, is going to use these 2 carbons to count towards the ones he's sharing, towards the entire 8. So he's going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons, and he's happy. So essentially, it's just electrons that are shared between 2 atoms. And again, it happens between a nonmetal and a nonmetal. So all of these guys in yellow, if both atoms in your bond are from those 2, or both from this nonmetal section or from this guy too, you can consider that a covalent bond, So yeah, that's all. I hope that made sense.